Okay, today in class we looked at solving systems by substitution. When we looked at solving a system, first we got to remember that if we're going to solve a system, no matter how we're going to do it, in this case we do by substitution, but no matter how we do it, all we want is the intersection, which just means what does the y equal, what does the x equal when those two lines intersect. Before today, all we knew how to do was graph to solve a system. So I'm taking this system, it's one of the ones off your homework, but let's solve this by graphing. Y equals x plus 8. Is that in slope-intercept form? Yes. So I can graph this. I put the x-intercept on there, or the y-intercept 1, 2, 3, 4, 5, 6, 7, 8, which is here, and the slope, which is 1 over 1, up 1 over 1, up 1 over 1, something like that. Okay. The second line, I need to get it in slope-intercept form if I want to graph it. Minus 3x, y equals negative 3x plus 12. Y-intercept is 12, slope is negative 3 over 1. So y-intercept is 12, down 3, 1, 2, 3 over 1. And we've got the intersection, it's at the point 1, 9. So we've got that intersection. And we can solve that by graphing. What we want, and what we talked about today, was a quicker and better way. So let's restart with this problem. Y equals x plus 8, and y equals 3x. Y plus 3x equals 12. Okay. The trick is that if all I want to know is what x and y are when they intersect, then if I know what x or y is, I can go put it in the other problem. I can just plug it in and see what I get. So what we said today is, if I have a variable by itself, like say y here, if I have a variable by itself, then I know what y is equal to. Y is equal to x plus 8. Y is equal to x plus 8. So if I know what y is, why not just go stick that right here in this y? I can just go stick it in the other problem. Stick in the x plus 8 right there, which looks something like this. I know that y is equal to x plus 8. So instead of writing y, I'm going to rewrite the second equation as x plus 8, which is the same thing as y. Look, y is x plus 8. That's what it says, so I'm just plugging that in. Plus, I'm rewriting this equation, plus 3x equals 12. Put these together. X plus 3x is 4x plus 8 equals 12. Subtract 8, 4x equals 4. Divide by 4, x equals 1. Do we get the x value and the same x value that we got when we graphed it? Yes. So we got x equals 1. We got the x value. How could I figure out what the y value is? Well, why don't I just take this and go put it back in one of these, like maybe this top one right here. Y equals 1 plus 8, because x is 1. Y equals 1 plus 8, y equals 9. And I know where those two intersect without having to graph. I can figure out where those two lines intersect without even having to graph it. Okay, so what we said in class today, the best way to be able to solve by substitution, here's what we got to do. First, we got to get a variable by itself. We have to get a variable by itself. It doesn't matter what it is. We're used to getting y by itself, so that's probably the one we'll try to get by itself. But we want to just get a variable by itself. And once you've got a variable by itself, then you can just substitute the whole equation in there. Substitute that equation into the other one. And that's what we did. We took this, we got this variable by itself, y equals x plus 8, and we substitute that equation into this one, and then we solved, and then we substitute again at the end. So let's work out a few of these off your homework that you haven't already done. Keeping these 4 rules in mind. Get a variable by itself, substitute, solve, and then substitute and solve. So let's go ahead and do this. I'll start with the easier ones. It turns out the only time we're going to use substitution is if it's easy to do this. We want to make sure this is easy, because then this is a good way. If that's not easy, we're not going to. So let's do a couple off this worksheet. Let's do number 2. X equals y plus 2, 2x plus y equals negative 2. First thing, check. Is this variable by itself? Yes. That's by itself. Do I know what x is equal to? Yes, I know what x is equal to. It's equal to y plus 2. So I'm going to go down here and plug it in for x. 2. What is x equal to? It's equal to y plus 2 plus y equals negative 2. Solve 2y plus 4 plus y equals negative 2. 3y plus 4 equals negative 2. subtract 4, 3y equals negative 6, divide by 3, y equals negative 2. So now I know what y is negative 2. Am I done? Do I know what x is? No, so I plug it back in, right there. Negative 2 plus 2, which is 0, so x equals 0. 0, negative 2. And that works. Let's skip down here a little bit. Let's skip to number 3. On number 3 it says 2m equals 2n plus 2 and 3m minus 4n equals 1. First thing you want to do on these things is make sure you have a variable by itself. Do I have a variable by itself anywhere? No. So can I get a variable by itself? Sure, I'll get a variable by itself. So I want to make this variable by itself. So I'm going to divide by 2 because that gives me a variable by itself pretty easily. And this just tells me m equals n plus 1. What can I do now? I have a variable by itself. So I'm going to go plug this in for m, because I know what m is. 3 times n plus 1 minus 4n equals 1. 3n plus 3 minus 4n equals 1. Combine like terms, negative n plus 3 equals 1. Subtract 3, negative n equals negative 2. Divide by negative 1, divide by negative 1. N equals 2. Okay. N equals 2. Do I know what m is? No. Well, look what I can do. I can go plug this back in into this equation. N equals 2. 2 plus 1 is 3. That's what m is. So you can do one like that. How about one where it's not quite as easy? How about I want to get one of the variables by itself on this one? How can I get one of the variables by itself on 5? Well, how about the bottom one? Why don't I just get these 3 w's and move those over? I get t equals 2 minus 3w. Do I have a variable by itself? Do I know what that variable is equal to? Yeah. So what can I do? I can take this and I can plug it in for t right here. Because I know what t is. It just told me what t is. So I can go 2 times 2 minus 3w, because that was t, plus w equals 5. I get 4 minus 6w plus w equals 5. I get 4 minus 5w equals 5. Subtract 4 from both sides. Negative 5w equals 1. Divide by negative 5. W equals negative 1/5. Which isn't the greatest. We're not a huge fan of getting things to work out like that. But if that's the way it works, then that's the way it works. I can go plug this back in now. I know what w is. So I can go plug that in right here. And I get t equals 2 minus 3 times negative 1/5. I get t equals 2 plus 3/5, which is t equals 2 3/5. So do I know what w and t are? Yeah, 2 3/5 and negative 1/5. Okay, we can go do one more. How about number 8? Get a variable by itself. Which one is going to be the easiest variable to get by itself? How about b in this one? It doesn't matter. We're going to get fractions on this one. So I'm just going to get one by itself and we'll see. Minus 4a minus 4a. Negative 2b equals minus 4a plus 10. Divide by negative 2, divide by negative 2, divide by negative 2. b equals 2a minus 5. I can take this, I can plug in for b right here. Negative 2a plus 3 times 2a minus 5 equals negative 7. Negative 2a plus 6a minus 15 equals negative 7. Positive 4a minus 15 equals negative 7. Add 15, add 15. 4a equals 8. Divide by 4, divide by 4, a equals 2. Do I know both? Do I know a and b now? No, but I can go plug this in here. And 2 times 2 minus 5 is negative 1. 4 minus 5 is negative 1. b equals negative 1. I got them both. Done. Let's look at this word problem at the end and then we'll get done. A movie theater is selling adult tickets for $5 and student tickets for $3. They sold 40 tickets and made $174. How many of the student tickets were sold? Well, here's what we can do. We've got the number of adult tickets and we know each of those is $5. I also know that the number of student tickets is in relation to the adult tickets. Well, if there's 40 tickets total, let's set this up with a chart. We can do this better. Set this up with a chart. Cost, amount. Here's adults, students, totals. So how many tickets were sold total? 40. Adults were $5, students were $3 total. There's no total cost, so we're not really worried about this one. Just cross that one out. We know this is total amount is x. This would be 40 minus x. This would be 5x, 3 times 40 minus x. And this should give me my total cost, which is 174. Now I can set up this equation. 5x plus 3 times 40 minus x equals 174. I get 5x plus 120 minus 3x equals 174. That gives me 2x plus 120 equals 174 minus 120 minus 120. 2x equals 54, divide by 2, x equals 27. What did that tell me? 27 was a number of adult tickets. So student tickets were 40 minus 27, which is 13. This is 27, this is 13. So I know how many of the student tickets were sold. There's 27 adult and 13 student. And we're done.